In this video, I will show you how to solve polynomial inequalities such as these. We start by solving the related equation. Basically, pretend this is an equal sign. That would give us x equals 4 and x equals -3. These are called the critical values. We then use those critical values to set up a number line like this. Let's see, so I've got -3 and 4. So I need to check each one of these intervals. Now, because we want the values where the function is less than 0, not equal to 0, all of these are going to be open circles. So open circle here, open circle here. Let's see, in this first interval, I could check the value of the function at -4, for example. A nice value between -3 and 4 is 0, so I could check the value of the function at 0. To the right of 4 is 5, so I could check 5. So let's check each one of these in the original inequality and see if they work. So with the -4, that would be -4 minus 4 and -4 plus 3. And I'm checking to see, is that less than 0? So this would be -8 and -1. So that's going to be +8. Is 8 less than 0? No. All right, that's a positive number. So this no means that -4 is not a solution, which means that none of the values in this interval are solutions. So I simply leave that blank. Now I'm going to check 0. Okay, at 0, I've got 0 minus 4, 0 plus 3. And is that less than 0? Well, that would be -4 times 3. So that would be -12. And yes, that is less than 0, which means I will have solutions in this interval. And then finally, I will check the number 5. So that would be 5 minus 4, 5 plus 3. And is that less than 0? Well, that would be 1 and 8. So that's 8. And of course, that is not less than 0. So that's a no. So there are no solutions here, which means that this graph represents all of my solutions. So in interval notation, that would simply be -3 to 4. So this would be the answer to problem number 1. So problem number 2, again, I need to solve the related equation. So that's going to give me x is equal to 4 and x is equal to -1. So these are my critical values, which I will use to make a number line. So here's -1 and here is 4. Okay, these critical values represent where the function is equal to 0. Since I want the values where the function is greater than or equal to 0, these values should be included in the solution set. So I'll make them closed circles. So now I need to pick a value in each zone, in each interval. So for example, I'll check f at -2 for this interval. I will check f at 0 for the middle interval. And I will check f at 5 for the final interval. So let's start with f at -2. So substituting 2 in here, I'm going to, well, -2. So that would be -2 minus 4, -2 plus 1. And is that greater than or equal to 0? So this would be -6 times -1. So that would be +6. and that is greater than or equal to 0. That's a yes. So that means I have solutions in this interval. All right, now I will check 0. So that would be 0 minus 4 times 0 plus 1 is greater than or equal to 0. Well, that's just negative 4 times 1. So that's negative 4 is greater than or equal to 0. That's false. That's a no. So I have no solutions in the middle interval. And finally, I will check 5. So that would be 5 minus 4 times 5 plus 1 is greater than or equal to 0. So that's going to be 1 times 6. 6 is greater than 0, so that's a yes, which means I have solutions in this interval. So now I will back up, zoom out, and write my final answer in interval notation. So that's going to be negative infinity to negative 1, bracket, and then union 4 to infinity. All right, so this is the solution in interval notation. So again, for number 3, I'm going to start by solving the related equation. And setting each of these equal to 0, I get the critical values, x is equal to 1 and x is equal to 4 over 3, all right, which is approximately 1.3. So I will use this to set up my number line. Okay, so I've got 1, and I've got 4 over 3. Okay, so which is, like I said, this is approximately 1.3. So this is going to be a little bit tricky because there's not a lot of daylight between 1 and 1.3. This is going to force me to choose a decimal. All right, but we'll deal with it. We can handle it. It's not that big of a deal. Because of the or equal to, that tells me that these endpoints should be included. All right, these are the places where the function equals 0, and we want that. Okay, so now I'm going to check a value in each interval. So I'm going to check f at 0. All right, I'm going to check f at 1.2. And I'm going to check f at 2 and see what happens. All right, so at 0, I've got 0 minus 1. All right, 3 times 0 minus 4. So that's going to be negative 1 times negative 4. Oh, and I'm checking to see, is this greater than or equal to 0? Well, that'll be positive 4. So that's a yes. So that means I have solutions in this interval. Now I'm going to check that 1.2. So this would be 1.2 minus 1. And this is going to be 3 times 1.2 minus 4. Okay, is this greater than or equal to 0? All right, so this is going to be positive 0.2. Okay, 3 times 1.2. Okay, so that gave me 3.6 minus 4. So now I'm going to have 0.2 times, and what really matters is that this is going to be something negative. I think this is going to be negative 0.4. I don't even need to know the actual answer. what I really need to know is that this is going to be a negative number. So is that going to be a yes or a no? Obviously, a negative number is not greater than 0, so that's a no. So there will be no solutions in that interval. Wait, this is 0.08, but anyway, let's move on to the last value. So f at 2. So this is going to be 2 minus 1, 3 times 2 minus 4. And is that greater than or equal to 0? So that's just going to be 1, and then 6 minus 4. So that's just going to be 2. So yes, 2 is greater than or equal to 0. So that means I have solutions in this interval. So in interval notation, I have negative infinity to 1, union 4/3 to infinity. So that's answer number 3. All right, this problem seems a little extra. If I solve the related equation, I'm going to have 3 critical values. Is that really necessary? I find this tedious. -2, 3. Okay, 3 critical values. Oh joy. Okay, so let's see. We've got -8. We have -2. And we have 3. All right, so we're going to have to check f at, let's say, -9. And f at -3. And f at 0. And f at 4. Let's see. Because of the or equal to, all of these should be closed circles. All right, let's start with -9. Okay, so that would be -9 plus 8 times -9 plus 2, -9 minus 3. Okay, so that's going to give us -1 times -7 times -12. Okay, so that's going to give us a negative number. So that is not going to be greater than or equal to 0. That's going to be a no. So we will have no solutions in the first zone. Okay, now let's check -3. So that's going to be -3 plus 8, -3 plus 2, and -3 minus 3. Is that greater than or equal to 0? So that's going to be 5, and -1, and -6. Okay, so this is going to give us a positive answer. So that's going to be a yes. So we will have solutions in this interval. Okay, now let's check 0. All right, if I put in 0, then I've got 0 plus 8, 0 plus 2, and 0 minus 3. Is that greater than or equal to 0? Well, that's just 8 times 2 times negative 3. All right, all that really matters is that this is going to be a negative number. So is that going to be greater than or equal to 0? No. So I have no solutions in that interval. And finally, let's check 4. So that's going to be 4 plus 8, 4 plus 2, and 4 minus 3. And we're checking to see if that's greater than or equal to 0. So that's going to be 12 times 6 times 1. Okay, so again, that's going to be a positive number. So that's a yes. So that means I have solutions in this interval. So now I'm ready to write my final answer in interval notation. So I'm going to have bracket -8 to -2. All right, that's this interval. Union 3 to infinity. All right, that's this interval. So this is the solution set for number 4. For number 5, they did not factor for us, so we'll have to do that ourselves. Luckily, this factors pretty easily. X squared is just going to be x times x. 4 is going to be 4 times 1, both positive. So look, we need to start by solving the related equation, though. So that would give us x equals -4, x equals -1. These are the critical values, which we will graph on this number line. So let's see, I've got -4 here and -1 here. So I need to do some test values. So in the first interval, I'll do f at -5. In this interval, I'll do f at -2. And in this interval, I'll do f at 0. You know what? I like to color coordinate these. Hold on. Okay, f at -2. F at 0. Because of the or equal to, these endpoints should be included. So I will show that with closed circles. So let's see. Let's see what happens at -5. So that would make this -5 plus 4 times -5 plus 1. Is that less than or equal to 0? So that's going to make -1 times -4. Okay, that's going to be positive 4. So that is not less than or equal to 0. So I'll have no solutions in the first interval. Now, what about -2? So that would be -2 plus 4, -2 plus 1. Is this less than or equal to 0? Well, that would be positive 2 times -1. So that's going to be -2. And yes, that is less than or equal to 0. So I will have solutions in this interval. All right, checking 0, I would have 0 plus 4 times 0 plus 1. And is that less than or equal to 0? Well, that would just be 4 times 1, which is just 4. So no, that's not less than or equal to 0. So I'll have no solutions in that interval. Okay, so my final answer is just this interval, which is from -4 to -1 with brackets. So this is the solution set for number 5. All right, I think this will be the last problem for this video. Again, we have to factor ourselves. So, so this is going to be x minus 7 times x minus 7. So that's going to give me one critical value, x equals 7. All right, well that makes it easy. So if this is 7, and again this will be a closed circle because of the or equal to part of it. So I only need to check 2 intervals. On the left, I'm going to go with 0, and then on the right, I'll go with 8. Okay. Now for the 0, it's actually easier for me to plug in 0 right here. So that just immediately gives me 49 is greater than or equal to 0, which is true, which means I will definitely have solutions in this interval. All right, now I'm going to check 8. So that would be, and I'm going back to the factored form now, 8 minus 7 times 8 minus 7. And is that greater than or equal to 0? Well, that's just going to be 1 times 1. So yeah, so 1 is greater than or equal to 0. So that means I'm going to have solutions here as well. That means everything is going to be a solution. So in interval notation, the solution set should simply be negative infinity to positive infinity. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.